Hello champs, this is class 10 science chemical reaction and equation. This is a part 6. Now in this video we are going to discuss about how to write the chemical balanced equation. Okay, what is the method through which we have to write these equations? Okay, so let's move on. Now, so for an example, they will give you the condition like this is given. Methane burns in oxygen to form carbon dioxide and water. And you have to write the balanced chemical equation. Okay. So the first step is first write down the word equation based on whatever the information that is given. So we will write first the reactants and then we will put an arrow and then we will write the products. Okay. Now where are these reactants and products are, that is given to you. Methane burns in oxygen, that means methane plus oxygen, and form carbon dioxide and water. First write this is in English. Now you may be thinking that how do we know that this will only get formed? So this you need to remember, because there is no formula to get that what will be the product. This is based on the several experiments scientists have done till date. Okay, so based on that they have written down that when you mix these two items you are going to get these products. So for an example, in your family, your mother knows that what items should mix and what you will get. Okay, and that is based on the past experience. Same thing here. So first you have to write this word equation. Clear? Now the second step what we are going to do, we have to write the formula for these compounds that you have written in the reactants and products. So methane is CH4, oxygen is O2, CO2 is carbon dioxide, H2O is a water. Okay, and this also you have to remember that what is the compound name, or so what you call that as compound in English and what is the formula for that. Okay, in the end of this video I have given the exhaustive list of those compounds and that you can refer with. Now the third step is start balancing by any method, whether the hit and trial method or the algebraic method or the formula method that we learned in the last video. So start balancing, and once we balance this, okay, so the next step is make this equation more informative by adding the physical state, by telling out what are the heat changes, what is the condition under which the reaction takes place. If you know that, for an example, I have put that gas, so all the physical state has been written. Heat, that means it's an exothermic reaction. Okay, it's a combustion reaction, we have already learned that, methane burning. So, and condition, sometimes you know, if certain condition are required, you just write down here. Okay, if not, then you can leave it. So this is how you have to write the 4-step method. Okay, so you'll practice few more equations so that you are used to this method for writing. Okay, so let's try one more, and then you can write further any other information that you know. For an example, I have shown this picture just to demonstrate. Okay, it is not mandatory to show this picture, but if you know some other information you can write that. Okay, can you please write the equation for this? On adding an aqueous solution of sodium hydroxide to an aqueous solution of copper sulfate, copper hydroxide is precipitated and sodium sulfate solution remains in the solution. So simple. The first we will write a word equation. So we write copper sulfate, sodium hydroxide, we put an arrow, copper hydroxide and sodium sulfate. Clear? So first step is the word equation. Second step, write the formula of these, and that's what is written here. Copper sulfate is CuSO4, sodium hydroxide is NaOH, then copper hydroxide is CuOH whole twice, and sodium sulfate is Na2SO4. Now the third step is we are going to balance that. Okay, so you can use any method, formula method or the hit and trial method, choice is yours. Okay, it will not change the answer. And after that start adding the states in that. So if you remember, they have told that copper sulfate is an aqueous solution because it is getting dissolved in a water. NaOH is also an aqueous solution, so I write NaOH because they are solutions. That means what they have done, they have taken a water and inside that they have added a NaOH. So this solution is there. Similarly, they have copper sulfate they have added in a water. This is an aqueous solution. So when you get that, here you get a copper hydroxide. This is a precipitate. What is precipitate we are going to discuss, but it is nothing but a solid. Okay, like when the milk gets spoiled, you get some sort of a precipitate. That is nothing but a similar kind of thing you get. Okay, so sodium sulfate is also an aqueous solution. This remains in the aqueous. Clear? So that's how we should write the 4-step. Now let's try one more, whether you can write that or not. Okay, so now, yeah, so before moving to that, we will discuss the few items. In this case, we have discussed the iron oxide. So iron contains the few oxides. The first one we remember, the iron oxide. Okay, so iron, whenever the iron balance is 2, so this one I can write as Fe plus 2 and O minus 2. So here the iron valency is a plus 2. Remember, we have learned the different metals. For an example, sodium, magnesium, aluminium. Okay, all these metal have just a one valency. That means Na is plus, Mg is plus 2, Al is plus 3, like that. But there are few compounds which shows more than one valency, and iron is one of them. So if you see here, iron shows plus 2 valency also and plus 3 valency also. Whenever it shows plus 2 valency, the name is iron 2 oxide. We clearly write this 2 is nothing but a valency of that. The common name of this we call iron 2 oxide, and this is also called ferrous. Remember this us, OUS. Clear? Whenever the iron has plus 3 valency, this is plus 3, this is called iron 3 oxide, or also I call ferric oxide. Remember this ric. Okay, so ferrous and ferric oxide. So these are the two. This is FeO, this is Fe2O3. Another thing to remember, that iron make a third oxide which is a mixture of these two. Okay, so the compound formula is Fe3O4. The name of this is iron 2 and 3 oxide because it shows both the iron. Also we call magnetic iron oxide because this shows the magnetic property. We also call this is magnetite. Okay, we will learn the ore of the iron, then we will learn the metals and non-metals. When we will learn the refining, we will discuss that. But this is just for you to remember. Okay, now let's see a little bit more detail about them, that how they look, what are the properties. So iron oxide valency is 2, we discussed. Common name is ferrous oxide. This iron oxide is found 9% on the earth mantle. That means if 100% iron that is found on the nature, okay, on the earth mantle, 9% out of this is FeO. It's primarily black in color, as you can see here. Okay, it looks like to a rust. Okay, this can be artificially prepared by the thermal decomposition of iron oxalate. Okay, this is a compound through which we can make this iron oxide artificially, that means in the lab or in the industry. It is not found in the nature like that. It is mostly used in a tattoo making or in the cosmetic because it is a non-toxic in nature. It is not toxic. Okay, so Fe2O3, this is a valency of iron where 3, ferric oxide, naturally found as hematite. Fe2O3, this is called. Hematite is an ore. So because all these iron oxide, they are not found in its pure form, they are found in the form of ore, and the name of the ore of this compound is hematite. From that, through refining process, we get this Fe2O3. This is generally used for steel industry. Okay, a lot of steel is used all around us. Others are used for pigment industry, jewelry industry, cosmetic industry. It is also used for magnetic recording. Can be found in magnetic disc, magnetic tapes for audio and video recording. It is found in two different colors. Okay, so that's why it is used in pigment industry, red and yellow. Clear? Okay, so the third one is Fe3O4. We have already discussed. It is a mixture of two oxides, FeO plus Fe2O3. Its appearance is black in color. Okay, but it doesn't look like a rust. Since this is magnetic, it is used in MRI. That is a magnetic resonance imaging scanning. In its intravenous form, it is used to treat anemia. Okay, because anemia is the deficiency of iron. Okay, so it is also used in that, widely distributed by pharmaceutical companies. It is a catalyst in Haber process. Down the line you will learn Haber process to produce the ammonia industrially. So this Fe3O4 is used as a catalyst to speed up the reaction. It is also used to in a water gas shift reaction. Okay, this is production of hydrogen, cost efficient production of the hydrogen. So Fe3O4 used there. Now let's practice few more. Heated iron metal react with a steam to form iron 2,3 oxide, that is Fe3O4 and hydrogen. So pause this video and start writing. Let's see whether you can get that or not. Okay, so how we will do that? First we will write the word equation as our learned process. So iron plus steam, iron 2,3 oxide plus hydrogen. Second step, we will write the compound formula. Iron we know Fe, steam, but this is a steam is of water, so we'll write H2O. Then Fe3O4 and H2 is a gas. Third step, we will balance it. So we balanced by any formula, okay, by formula method or by hit and trial method. And fourth step is we will put the states or any other information that we need. So finally, this is your final equation. Clear? So see how easy it is if we follow this step by step process to find the completely balanced equation. Okay, there will not be any kind of confusion. Clear? Let's try. Hydrogen gas combined with nitrogen to form ammonia. So this is the manufacturing plant, okay, where the ammonia is produced. So, and you can see here a human, so small in comparison to this, so big. Okay, it's a huge power plant. Yeah, so let's come back to this, how we will write this. So first is write in English, hydrogen plus nitrogen is ammonia, and then write the formula. Then third step is balance, and fourth step is write the state, because all three are gases. That's it. Clear? Okay, you can write here what is the temperature and pressure condition also, okay, if you know that. Okay, let's try a few more. Sodium metal reacts with the water to give sodium hydroxide and hydrogen. Yes, so how will you do that? Exactly same process. First write the sodium plus water, the word equation, sodium hydroxide, write the formula, Na plus H2O, give NaOH plus H2. Third is balance the chemical equation. Third step. Fourth step, write the state. Okay, remember whenever this water is given, we will write NaOH, because water exists, we will write an aqueous, we will not write a solid, because the water exists, it will get dissolved in the water, so it's an aqueous solution. Clear? Yeah, this is how we can see that. So sodium reacting with the water to form sodium hydroxide, it's a basically kind of explosion happens. Okay, so we need to be little bit cautious when you do this kind of experiment. Okay, sodium is a very reactive metal, that's why sodium is kept in a kerosene. You can see this is a kerosene. This sometimes this question comes that why sodium and potassium is stored in a kerosene, because they are very highly reactive metals. They react with oxygen in air even at the room temperature. So if we keep it anywhere, it will oxidize, whereas when kept in kerosene, it does not come in contact with air and does not oxidize, so does not burn. That's why it is kept like this. This is a kerosene in this container. Clear? Okay. Now let's Write the next one. Magnesium burns in oxygen to form the magnesium oxide. Okay, see, the idea is there are so many reactions exist in the nature. What we are trying to learn, we are trying to learn all these reactions, okay, by step method, and uh, uh, understand their usefulness, understand some extra information about those reactions so that we can remember. Otherwise those will look like an alien equations, you will just mug it up and that will not help. So in this case also we will write the magnesium plus oxygen, it's a magnesium oxide. So we wrote a word equation, write the formula, okay, and we can simply balance it. This is very easy, even by hit and trial we can balance, just we have to put the 2 here, it is balanced, and 2 here, and fourth step just at the state. Clear? And this we have seen already that if we take a magnesium ribbon, okay, and it burns with a dazzling sound, dazzling light. Now the question comes why, okay, sometimes in this question comes like this magnesium ribbon, okay, ribbon is nothing but a sort of a wire, okay, you will take something like this is a magnesium wire. Before burning it, we need to take a sandpaper or a scotch brite kind of thing, okay, sandpaper, and we need to rub it, okay, before burning. And why we do that? That's the question comes, that why we need to rub the magnesium wire with a sandpaper before performing this experiment. The reason is that magnesium, in the presence of atmospheric oxygen, this layer, outside layer, okay, or the outer covering get oxidized. So if you burn without rubbing it, what will happen? This magnesium oxide will act as a layer and it will not allow magnesium to burn further. So in order to avoid that, first what we do, we rub it by sandpaper so that magnesium oxide layer on the outer surface is removed, and that we can do by sandpaper. Okay, and once we do that, we put that on a you can see here, okay, this is a burning stove, and if you bring it, it starts burning with a dazzling light. And finally in the bottom you will get a ash kind of thing, you can see here, this is a ash in the china dish, and this is a white powder we call magnesium oxide. Make sure you hold this magnesium ribbon with a pair of tongs, because magnesium is a metal, okay, the heat will conduct. If you touch by hand, you can burn your hand, so that's why pair of tongs is used to hold this. Clear? And in this we are giving the heat, so you can write here like this. Clear? Okay. So similarly you can write many reactions. These are the common chemical names and their compounds, okay. So pause and note down on a piece of paper, okay, and stuck where you study. You cannot remember them in a single shot, okay, so you have to remember slowly. Here the common name is also written. For an example, if you take a NaCl, this is a sodium chloride, but if you go in the supermarket and say, hey, give me 1 kg sodium chloride, the person will slap you, isn't it? Because you need to tell the common name, that is a give me 1 kg salt. Similarly, these compounds have some common name. Commercially, if you want to buy them, you will tell these common name. You will not tell these chemical name. These chemical name is for our for us like science students. Okay, so for an example, we will not call acetic acid, we will call vinegar. Okay, even though the name is same. We will call the baking powder, we will not call sodium bicarbonate or sodium carbonate, we will say washing soda. Clear? We will not say I have brought a chalk, but as a science student we will tell I have brought a calcium carbonate, whereas in the market if you go, you will not call calcium carbonate. Clear? So these are the few compounds that you should remember. Now the next few more is there here, okay. So this is not an exhaustive list, but at least these two names you should remember, okay. So here this is a iron pyrite, this is called a fool's gold, Okay, this question mark is nothing, you should ignore here. This is a calcium sulfate. Yeah, this is called heptahydrate. This is a hepta, and here also we will write 7. Yeah, this is some typing mistake. So pause this video, note down all these, they will be very helpful for you, they will be your friends. Okay, so thank you, see you with the next video.